Okay, we're going on now to Part B, or Part 2 of Section 5, so we don't keep this too long. And we're asked to graph the open interval this. So the strategy would be to have a number line. And the point we're interested in is right there, which is a 3. Now, what symbol will we put to indicate a parenthesis? Because this is in interval notation on our graph. And the answer is we're going to use that parenthesis. And then this indicates it's going on to positive infinity. And there's the graph of this. Now, sometimes they ask us to put it in algebra. Well, how would we write this in algebra? And we would say x is greater than 3. Now, notice 3 is not included in this system. This would have had a little circle over it, a hollow. That's why we have a parenthesis. All right, let's check this out, see what we have here. Good. All right, now they want us to graph the open, half-open interval. And again, we're going to have a line. Now, what values are we going to put on this line? Well, we're going to put 1 for 0 and 1 for 4. Now remember, x is in the middle, so this part is darkened. But what symbol do we put at the 0? A parenthesis or a bracket? Well, in this case, it's just a parenthesis. And for the 4, because it's less than or equal, it includes the 4, so we put a bracket. And then this is what we call half open. This is the open part. This would be the closed part. And then interval notation for this, right from the graph, it's a parenthesis, 0, 4, bracket. So we see it there. There's the graph. Okay, now in this one they're asking us to represent the following graph using algebraic notation and state what kind of interval it is. So, again, we're going to say x is what here? Is it just greater than or equal to? And it's greater than or equal to because it's a bracket here, and it starts at 1. And then interval notation would be, again, right from the graph, bracket 1 to positive infinity, and it's half open. This is the open part. This part would be the closed. And again, they're using that to designate that 1 would have had a dot on it because 1 is included in the set. If it was only greater than, we would have used a parenthesis here, just for review. Okay. Now, for this next one, it says this represents half open interval, and this represents half open because the infinity out here has a parenthesis. This has 2 parentheses, so this is referred to as an open interval. And in interval notation, again, right from the graph, we're going to put a parenthesis, -3, comma, 3. No, 1. Oh, I got carried away there. The 1 right there. Again, open, that is both parentheses. These would have little hollows on them because the -3 and the 1 are not included in the set. Okay, now in example 2, we're looking at illustration of a union. And union, you recall, is this symbol. And let's plot these on a graph. And what we would do for something like this, the numbers we're interested in is a 5. Well, we better put the 5 here so we have enough room. And a 4 there. Okay. Now let's do this one first. It says x is greater than 5. So we'll use a parenthesis and an arrow like so. And now this one, or it's going to be a union, x is less than or equal to 4. So we're going to use a bracket here. A line going this way. So because it's a union, we indicate this with a U, and if we're going to put this in interval notation, it would go from -infinity out here, comma 4, bracket, the union symbol, and then picking up here with a parenthesis, 5, comma, going to positive infinity. So we're showing union, we're combining this and this on a single graph. And let's see how they do it. So there's one, there's the other, and they put them on one graph. Okay, now in example 3, we're doing what is called intersection. And you might say, how do we know that? Well, because of this bold-faced word and. This is an intersection. So let's graph this. There's our line. And we have a 0 there. Let's get the right pen here. And we have a 2. Now, we could put these on two separate graphs and then see something, but we'll put them on one graph because it's an intersection. So let's do this one first. It says 0 is greater or equal, or x is greater or equal to 0. So we're going to put a bracket here, and then our line goes this way. Now, I'm going to change colors now, because I'm going to put this one on the same graph. X is less than or equal to 2. So at 2, I'm going to put a bracket, and then this line goes this way. Now again, we have an and, an intersection. So we're saying, where do they intersect? Where do they overlap that you have a red and a black? And the answer would be here, at 0, 2. Now, how could we write this algebraically? Well, we could say that x is greater than 0, or x greater or equal to 0. X is less than or equal to 2. So this would be another way to write this. Again, because of intersection, we only use the part they overlap. Now, how about if they had the word or here? What would this be like? Well, we would include everything. And the answer here would be a solid line, and that would represent all real numbers. Okay. And let's see what they have for us here. It's nice we can see it done officially. There's one graph, there's the other, and there's where they overlap. And it's because we are only using the part where they intersect. And if we were going to write it algebraically, we'd write it this way. Now, if we put braces, an X in front of the whole thing, this is now in set builder notation. X is such that 0 is less than or equal to X, X is less than or equal to 2. Okay. Now, we're going to move into solving inequalities. And inequalities are very similar in how we solve them as we did with equations, and we spent a lot of time. Now, there are a couple of little differences, and I will outline that to you when we get there. Now, if you'd like to pause and read this, go ahead. And pause and read this. This does mention the one little difference, but I will describe what's in red when we get to it a little later. Okay, so we want to solve this inequality. And again, write it down, pause it if needed, and then we'll start solving it. So we're going to get 6x. We're going to transpose our positive 5 to this side, where it becomes a negative 5, so this is negative 6. We're going to divide both sides by 6, just like we did equations. So this cancels out. X is less than or equal to negative 1. Now if we're going to graph that, it's negative 1. What symbol do we put on our graph here? Less than or equal to, bracket or parenthesis? Bracket. Which direction does it face? Right or left? X is less than. It's going to be left. Now let's put that in interval notation. It's coming from negative infinity, so parenthesis, negative infinity, comma, negative 1, bracket. All right, let's see it. And they're using the horizontal method, showing us in detail. And there's our answer. And then there's our graph. And there it is in interval notation. So again, you can pause this, look at it, study it. You want to be able to duplicate it. Okay, let's do this one. Take time to write it down. I'm going to be writing these in my notes as this might be a quiz question. So I'm going to transpose the x to this side, where it becomes a negative x, negative 1x, 3x gives me 2x. Transpose this to this side, where it becomes a negative 7. So here it was a positive 4, over there is a negative 4 on this side, add them and I get this. Divide both sides by 2. Now I get x on this side, and it's a negative 2, negative 7/2. Now, it's not a good idea to leave the x there. Most students have trouble graphing this, so I would suggest you rewrite it. So the x goes on the left. Now notice the inequality sign is, the point is pointing toward the x. So when you rewrite it, you put the point toward the x, negative 7/2. So when you graph this, negative 7/2, what symbol am I going to put here? A parenthesis or a bracket? A parenthesis, facing right or left. X is less than. And if you said left, it's correct. Now in interval notation, again, this is negative infinity out here. Negative infinity, comma, negative 7/2, parenthesis. And this would be an open notation. This point would not be included in the system. You'd have a hollow there normally. And they did all the things we did, so that was a good one. They didn't use anything different than what I did. All right, good. All right. Now, for this one, I'm going to do it, I would do it a little differently than what I'm going to show you, but I wanted to show you this way here too. So I'm going to take this x here, bring it over here, so this becomes a negative 5x on this side. Is less than, I'm going to move the 6 from this side over to this side, where it becomes a negative 6 on this side. So this gives me a negative 5. Now, here's where we have to be careful. Now, in order to get a positive x here, I'm going to have to divide by a negative 5. Now, the rule for something like this is, and I'll illustrate it to you, if I have 2 is less than 4, is that a true statement? Yes. Now, if I multiply this 2 by a negative 2, well, let's multiply by a positive 2 first. Then this is 4. And that is less than 8. Is that true? Yes, this is still true. But now, suppose I had used, as I said before, a negative here. Multiply this side by a negative 2 and this side by a negative 2. This now becomes negative 4 and this side becomes negative 8. Now, is this still true? Negative 4 is less than negative 8. And the answer is no. This is not true. And that was because we had an inequality and we're multiplying it by a negative. And it also holds true if we divide it by a negative. In order to keep this true, we had to reverse our inequality sign. And that was one of the rules they described earlier. So instead of it being less than or equal, we're going to reverse that. It's going to be greater than or equal. And why did we do this? Well, because we're dividing by a negative. Or if we multiplied by a negative, to keep it true, we have to reverse the direction of the inequality sign. Now, this is basically the only difference in solving equations and solving inequalities. That if you have to divide your variable by a negative or multiply by a negative, to keep the inequality true, you have to reverse the direction of your inequality symbol. So keep that in mind. All right, let's see what they've done here. Good, because they're doing it this way as well. Now, in order to get a positive 1 here, I have to divide by a negative. Now, when I do, notice what they've done. Here it was less than. They reverse the direction of the inequality sign. So you can put a little star in your notes to indicate that. And that's the answer. And plotting it on a number line, and then putting it in interval notation. You should include this in your notes as well. These are all going to be valuable as you study and work on your certification. Remember, for certification, you are allowed to use your notes. Okay, let's work this one out here. Take a moment to write it down. So we get 2x plus 5 is less than 3x. Now we have a negative sign in front of the parentheses. So what do? Well, we remove the parentheses and change the signs of what's inside. So this is a positive 7 will become a negative 7. This is a negative x. It's going to become a positive x. And now we don't have parentheses anymore. So we combine like terms. 2x plus 5 is less than 4x minus 7. Remember, there's a 1 there. Now, one of the things you'll note that I said, try to keep your x's positive. Now, if you keep your x's positive, you're going to divide by a positive. You don't have to change the direction of your inequality sign. So I'm going to subtract 2x from here, subtract 2x from there. This becomes 2x. Add 7, this becomes 12. I'm going to divide both sides by 2. I now get x, reading it this way, is greater than 6. And again, for simplification, I would suggest you rewrite it that x is on this side, and now the open sides are toward the x, and now it's easier to read. So if you're going to graph that, it's going to be 6, it's going to be a parenthesis this way, interval notation, parentheses, 6, comma, positive infinity. And again, these are still rather easy. So we're at 22 minutes now, so we'll stop this one, and I'll probably have one more on this.